Hey everybody, just want to welcome you to Module 11, Week 11 for ME 111 System Dynamics. A couple of big ticket items for this week. Quiz number 11, this has been posted to Blackboard and it'll be due on Friday the 13th by 4 p.m. The other big item here is exam number 2. This is your second midterm exam. This will be released on Wednesday morning, the 11th at 6 a.m. You'll have 12 hours to complete this and it'll be due that same evening, Wednesday the 11th by 6 p.m. This will have the same format as your other exam 1 and your homework problems. So please reference back to your homework guidelines for more information on the format, detail, grading, and submission. So another reminder here, my office hours, as always, are Tuesdays and Wednesday mornings from 9:30 a.m. till 10:30 a.m. Now, if this time doesn't work for you, please just send me an email, a message, or a chat through Teams, and we can find a time that works for both of us. So this week we're jumping into Chapter 11. So in Chapter 11, what we're going to talk about here is the control system design, in particular the root locus plots. So last week in Module 10, we discussed a lot of the feedback control system. So we're going to continue on with a little bit of that and try to develop a little bit more systematic approach to how we can optimize our systems using this root locus plot. So a couple things we're going to concentrate on within this section here. One, how do we sketch a root locus plot for lower order models? How do we use MATLAB to obtain the plots for the higher order models? How do we interpret and use these plots to determine the location of dominant roots and roots having desired properties such as the damping ratio and time constant? We're also going to look into determining the major features of the root locus plot and use it to assess the effectiveness of the proposed control scheme. We're going to use a couple different methods to design the controllers. We're going to take a look at designing a control system to avoid actuator saturation. We're going to design a controller incorporating the state variable feedbacks. We'll take a look at what the state variable feedback is, and then we're going to take a look at MATLAB and Simulink and see how we can integrate these as well. So this section, this module is going to be broken down into 3 different sections. The first section here is going to be our module 11.1. So this is going to focus primarily on our root locus plots and designing using these plots and how we can optimize and tune our controllers using them. So going along with our textbook here, section 11.1 is going to involve the root locus plots, and section 11.2 is going to be focusing on design using the plots. So moving on to our next section within this module, module 11.2, this we're going to talk about saturation, reset windup, and the state variable feedback, cover a couple examples. So this corresponds with sections 11.3, 11.4, and 11.5 in your textbook. The last section here, module 11.3, is MATLAB and Simulink applications. So I'll go through a couple of MATLAB applications. I'll include some of these in my lecture slides, and I'll post a couple of videos utilizing MATLAB for our root locus plots as well.